2021 Climate Change Hero event. And this year we're honoring Dr. Pierre Fogal. Just so we know people are out there, I would love to see just some exclamation points in the chat. If everyone can hear us and we're ready to kind of get going, I would just love to see everyone just put one exclamation point in the chat right now. Yes, there's Carol. Anyone can follow suit with Carol. That would be amazing. Oh, okay. Paul, thank you. Thank you. Okay, we are real humans and we're all real humans in this space together. Evan Ferrari, thank you so much. Yes, hello. My name is Braden Etienne. I will be your host this evening. I work for an organization called The Making Box, and historically we've done this event as an improv show in conjunction with eMERGE. But tonight's going to be a little bit different. I think we're going to run through the PowerPoint, run through the event, and have a chance to kind of improvise together as we ask Pierre some questions and have a discussion. There's a lot of change and adaptability here. And Rasha, I also thank you for starting the recording there. So yes, that's me. You'll hear more from me eventually. But before we kind of dive in to the rest of the event, I want to just throw it over to Rasha, who's going to do a land acknowledgement for us right now.
Hello, everyone. Thank you, Braden, for this intro. My name is Rasha Abusita. I'm the Sustainability Program Coordinator at eMERGE Guelph. I want to acknowledge, as we gather here, we are reminded that Guelph is situated on treaty land that is steeped in rich indigenous history and a home to many First Nations, Inuit, and Métis people today. As a community, we have a responsibility for the stewardship of this land on which we live and work, and a responsibility to foster reconciliation and respect for Indigenous people who have been stewards and caretakers for this land for generations. Today, we acknowledge the Mississaugas of the Credit First Nations of the Anishinaabe people on whose traditional territory we are meeting today. And we encourage folks to continue educating themselves on all current issues facing First Nation communities and peoples across Ontario and Canada, and to learn how to take action to uplift and support Indigenous people from coast to coast to coast. Thank you all. And next, I will hand the mic to Evan Ferrari, our Executive Director at eMERGE Guelph, to give his quick intro about eMERGE and climate change. Over to you, Evan.
Thanks, Rasha. I'll just ask you to move the slides for me to move on to the next slide. There we go. Sorry, one more slide. Oops, sorry, you've got to go back there.
Yeah.
Briefly, we just want to go through these slides relatively briefly. eMERGE fights climate change, and how we do that is under the mantra of getting our community to 100% renewable energy. Go ahead, Rasha. And that goal currently is at 2050, but we're going to talk for a few minutes about why we think that's really a little too late. Continue, Rasha. So while we have a 100% renewable energy target for the city proper, there's also a net zero carbon target for the entire city. So there's the corporation of the city of Guelph for the 100% renewable and net zero carbon for the community as a whole. Thankfully, the city last year acknowledges that we are in the midst of a climate emergency. Next slide. And the other recent thing that the city did that was very positive was that it demands that the province begin a phase out of fossil fuel burning for electricity generation, namely phasing out of the gas plants by 2030. We were able to get Guelph City Council to commit to this, and now there are 19 communities across the province that have done this. And just so that you know, next week it's going to Toronto City Council. It started in smaller communities and it's slowly getting to bigger and bigger communities. Next slide. Unfortunately, the city issued a report back in September that showed that this is the first yearly report on GHG emissions, showed that 2019 over 2018 actually saw an increase in GHG emissions, albeit a very small amount, but it wasn't a very good way to start off on our fight against climate change. Next slide. With the GHG emissions rising, technically it is indeed a step backward. And since we've acknowledged a climate change emergency, we must have reduced emissions when in fact we haven't. It is evident that no serious action was made if indeed all we've done is essentially be equal to the previous year. And frankly, what's becoming evident to scientists around the world is that 2050 is probably too late. Next slide, please. There we go. So what can we do next? How can we move forward as a city and as a community? Science is telling us that 2050 too late, and reevaluating the target that from our perspective is that we need to be bringing it closer at least to 2040, at least to 2040. Next slide, please. And what do we need to do in order to get there is that we need to entrench climate change. And we're talking on a local basis here. We need to entrench climate change action into the official plan. And what that means is, it sounds like really boring planning type stuff, but essentially this means that all decisions must have a climate change lens front and center. Every decision that the city is making, how will this get us to our climate change goals? How will this decision help us reach these climate change goals? And frankly, we have to show by evidence how the decisions are aligned with our targets. Oops. On to number 4 there. There we are. And finally, the opportunity that presents itself is that we've got some really great staff working for us at the City of Guelph. But we can't rely on climate change, on a couple of staff that are in that office that are fighting climate change. We have a lot of great staff working throughout that bureaucracy. We want to empower staff so that they can be part of the solution and bring solutions forward that they see in the daily work that they do, regardless of what department they're from. This isn't for the engineering department. It's not for the water department or the waste department. It's for all different departments of the city. We can't leave this to one small office. Thank you. I hand it back.
All right, hello. So before we get started, this event is you're going to get a lot more out of this event, I think, if we can start getting engaged, start thinking about questions to ask, and not be afraid of the chat box. So my goal right now, the only thing I want you to not feel is afraid of the chat box. So what I want to do is ask you just a couple of softball questions. This is a couple of softball questions. You should all be able to answer these very, very easily. And that way we can be comfortable with using the chat function so that when we get into discussion, there's no worries about asking questions and getting good conversation going, because I think that's going to make the event tonight is having all of you participate. So the first thing I want to do is I want everybody right now to write hello in the chat, but don't press enter yet. Don't press enter yet. I'm going to give us 10 seconds to just write the word hello. We'll count down from 5. And what I hope to see is an explosion of hellos of all you 17 people out there who are here watching the event. So here we go. 10 seconds to write hello in the chat, but do not press enter yet. Do not press that enter button. Just write the word hello. Add an exclamation point even if you want to be really enthusiastic. So 3, 2, 1. Press enter. I hope everyone said hello. Yeah, there we are. Hello, everybody. Thank you so much for coming. Let's do this again. Now I'm going to ask a little bit of a harder question here. So all I need to know is what you had for breakfast this morning. What you had for breakfast this morning. I'm going to give us 10 seconds to write what you had. Don't press enter yet. Don't press enter yet. 5, 4, 3, 2, 1. Let's see what everyone had for breakfast this morning. Oh my God, oatmeal, toast, nothing, and a smoothie. Smoothie with a side of nothing. We are all doing so great. Okay, this is just the last question. It seems like we're all getting very, very, very comfortable with the chat. And this one is maybe a little trickier, but I think we can do it. What is one thing you want to learn about tonight? What is one thing you want to learn about tonight? And I'll give us 10 seconds to load a chat. And we'll count down from 5 and do another explosion. 5, 4, 3, 2, 1. Let's see what we want to learn about tonight, everyone. Pierre, how equipment is working. Flight climbs. Did you get that, Pierre? Because these are all the questions that are burning in our mind. Thank you so much, everyone, for jumping in. We know how the chat works. We don't need to be afraid about it anymore. And at this point, I also just want to give a shout out. You might have seen one of the names in there. Lloyd Longfield is here, our local MP. So it's always nice to see MPs come to events like this and get involved in the conversation. So thank you to Lloyd for coming tonight, and thank you to all of you for coming tonight. At this point, I'm going to hand it off to Mark, who's going to introduce Pierre. But thank you so much for participating. We're ready to chat. We're ready to be engaged. Thank you for participating, everybody. Oh, hi, Lloyd.
Hello, can you hear me, everyone? Perfect. Hi, I'm Mark Colvin. I'm one of the board members for eMERGE, and I have the great pleasure to introduce Pierre Fogle, our speaker tonight. Pierre, a local boy, he was born and raised in Guelph. He grew up in the country on the edge of the east end of Guelph and attended Bishop Macdonell High School back when it was still on the hill. He then went on to receive an undergrad degree in physics from the University of Waterloo, followed by graduate work at the University of Denver. It was during this time that he met and married his wonderful wife, Teresa, of 27 years. They had 3 children, Alexander, Andre, and Serena. And Pierre's field of research is atmospheric composition determined through infrared spectroscopic study. And I'm sure everyone knows exactly what that is. He has done this using spectrometer located on aircraft, stratospheric balloons, and the ground. Much of his ground-based work has occurred in the Arctic and Antarctic. In 2004, he was recruited to help with the establishment of the Polar Environment Atmospheric Research Laboratory. It's known as PEARL, and it's located at 80 degrees north on Ellesmere Island in Nunavut. He has been the PEARL site manager since then. Previous to the COVID-19 pandemic, he typically spent about 3 months of the year in the Canadian High Arctic. Pierre is also a founding board member of the Guelph Renewable Energy Co-op. And with great pleasure, everyone, it's Pierre Fogle, the climate hero.
Okay, can you guys hear me? Okay, that's good. Let me see if I can share my screen here. Okay, so hopefully you can see my presentation now. So thank you, Mark, and thank you, Evan, for the very nice introduction, and Braden as well. So I'm going to talk a little bit today about what it's like to make measurements of the atmosphere in the Arctic. As Mark said, I'm the PEARL site manager, and my southern job description is that I'm a senior research associate at the University of Toronto. And as part of that, I'm a member of the Canadian Network for Detection of Atmospheric Change. So just a brief introduction to CANDEC and PEARL. CANDEC is the Canadian Network for Detection of Atmospheric Change. It's a consortium of Canadian universities and government scientists, and it was aptly described by our first principal investigator, James Drummond, as a coalition of the willing. So that was people who had an interest in making measurements in the Arctic and putting the infrastructure in place to do that. PEARL is the Polar Environment Atmospheric Research Laboratory. It's located in the vicinity of the Eureka weather station at approximately 80 degrees north and 86 degrees west. You can see the red balloon there about halfway up Ellesmere Island. And Ellesmere is that last bit of land before the North Pole that's a part of Canada. It's accessible only by aircraft and sea lift. And PEARL consists of 3 facilities: the Ridge Lab, the Zero Altitude PEARL Auxiliary Laboratory, OPAL, and the Surface Atmospheric Flux and Irradiance Extension, SAPPHIRE. Now I'll point out that when we named OPAL, we didn't know there was going to be anything that followed on. But of course, as soon as you're successful in doing one thing, somebody wants to be able to do something not quite the same, and could we do it where it's a little bit different? So we added in SAPPHIRE to satisfy those requirements. It's the second most northern facility of its kind in the world. There is one in Greenland that's just a little bit further north than we are. So where is the question I usually get, and how do you get there? Well, getting there isn't easy. And I like to show this graphic, this map from First Air. First Air is the self-described airline of the North. And there are two stops that are not marked on the map. The first is Toronto, where we all start out. And the second is Eureka. So even though the airline of the North flies many places in the North, it doesn't get to Eureka. So typically travel to Eureka takes 2 days. We fly from Toronto to Yellowknife on the first day. In Yellowknife, we will charter an aircraft that will depart the day after. And it's going to be 7 to 8 hours on a turboprop aircraft. And most of them are loud, they're cold, and they are cramped. A couple of interesting facts about the area. So the sun is not visible from the 20th of October to the 20th of February. The sun rose for the first time this year about 2 weeks ago. The sun is always visible from the 10th of April to the 29th of August. So no sunsets at all during that time. Sun is completely above the horizon. It's classified as a semi-arid desert region. So we get less than 30 centimeters of precipitation per year. And the picture you see there is of the final sunset of 2012. So that is right at noon. That's as much sun as we saw that day. Why do we have Pearl? Why do we go through the extremes of operating in such a far-flung corner of the world? Well, the polar regions are extremely important in global atmospheric circulation. This impacts climate, it impacts the weather, and the composition of the atmosphere. Not surprisingly, they are very much undersampled because most of the sampling, and by that I mean measurements of the atmosphere, happen where the people are, in the mid-latitudes. Understanding the polar atmosphere is critical to understanding and predicting the global atmosphere. And the best way to measure that atmosphere is to put state-of-the-art instrumentation where it needs to be. And this is the one of the things that we've done at Pearl that quite often was not done previously in the Arctic. The instruments that went up there tended to be less capable than what we would use in friendlier places. So we're going at it with the best we can get to do the job. Visiting the Arctic has a lot of important benefits, such as sovereignty, natural beauty, culture, resources. It's a really unique place to be. Some of the things that Pearl measures are around ozone depletion. So myself and a number of others were there in 2011 when we had what was then described as unprecedented ozone loss in the Arctic. We were all familiar with the Antarctic ozone hole, but this is the first time we saw this kind of ozone destruction in the Arctic. Because the Arctic is generally warmer, it does not happen as often or to the extent that it does in the Antarctic. And the plot here actually shows the differences from normal. So the more blue it is, the more it decreases. Hopefully you can see my cursor here. So the gradient is outward from here. We had something approaching 50% ozone depletion in the center of the ozone hole at the time. It happened again in 2020, and the amount of ozone destroyed was even greater than that of 2011. And in both cases, there was a team at Pearl during sunrise to make those measurements. So the Arctic is warming. This is work done by Glenn Lessons, who's a part of CANDAC and based at Dalhousie University. And what you see here on the left is the trend for 22 Canadian stations that fly balloons and what are called radiosondes up into the atmosphere. And the individual station records are in the light gray, and the means are in the dark black with a trend line through it. The interesting part is the dotted line here. So the dotted line goes from 1991 through 2010, and that is just for the Arctic stations. So while the rest of the atmosphere is warming at about 0.7 degrees per decade, the Arctic is warming at about 1.1 degrees per decade. So about half a degree more than it is per decade at lower mid-latitudes. The panel on the right shows you that most of that warming is happening here in the winter months. So the summers are not so different, but the winters are getting warmer. And we, in fact, are experiencing that anecdotally, in that we are not seeing the extreme cold days that we did 10 and 15 years ago. I don't think we approached minus 50 Celsius this year, and that was a fairly regular occurrence in years past. So why is this happening? There is this thing called the greenhouse effect, and the greenhouse global warming we used to refer to as greenhouse gases and what have you. But we stopped doing that in part because the greenhouse effect is a necessary for life on the Earth. Given where the Earth is with respect to the sun, if we didn't have an atmosphere that retained heat, it would be too cold. It would be an average temperature of something below zero instead of an average temperature of somewhere around 20 Celsius. And the key to that is on the left panel here, you can see the incoming spectrum from the sun. And there's a lot of light that comes in the visible. That's where the sun's output peaks. And there's a lot of light that comes in here on the right side of that in the infrared. And if you look at the right panel here, the incoming radiance comes down in, and then we have here the partitions of where that goes essentially. So we radiate 195 watts per meter squared back out to space as thermal radiation, another 40 directly from the surface. But here you can see that 452, so not quite half of the radiance, is kept internal to the atmosphere. Going back to the left panel here, you can see there is an arrow pointing up here on the right side of the left panel, and that is what the atmosphere releases back to space as long-wave radiation. So why that's important to Pearl is that we have instruments that measure both the incoming radiation and the outgoing radiation. So from time to time, I've been challenged on, well, how do you know that it's CO2 that's doing this? And well, it's quantum mechanics, basically. And so you see there on the left, a diagram of the CO2 molecule. You have a carbon atom in the center, and you have two oxygen atoms on the outside, and the oxygen atoms are connected to the carbon atom by a molecular bond. Now, it turns out that light hitting the CO2 molecule can excite that if it is of the right frequency and the right energy. And when it excites it, you get motions in the molecule. So in the second one here is a symmetric stretch, and then you've got a bending motion, and you've got an asymmetric stretch. All of these require different amounts of input energy, and that basically means different frequencies of light. So when the CO2 atom absorbs a photon of the right energy, it goes into motion. And that needed amount of energy is different for each motion, and it's particular to the molecular bond being affected. And so this yields what we call lines, or portions of light that have been absorbed. They're called lines because in the first ever spectrum recorded of the sunlight, they showed up as black lines because there was no light there. And the collection of lines forms the spectrum. So looking here on the right-hand side, you see a spectrum of the light. This is incident solar light that makes it through the atmosphere. You can see on the right-hand side of the top panel, carbon dioxide, a very strong absorption. That is the bending motion. you can see then towards the left side, not quite all the way to the left, another CO2 feature, and that is the asymmetric stretch, or sorry, that is the symmetric stretch. And then further down, there would be another one about here. It's not actually labeled, just the arrow, and that's the asymmetric stretch. Energy increases from left to right in this diagram. So the photons that are absorbed on the right-hand edge of the diagram are of lower energy than the ones that absorbed on the left-hand stretch. And you can see too, all the other molecules that are significant absorbers in the atmosphere, in particular ozone and water vapor. So here are some actual measurements on the bottom panel on the right-hand side from Eureka. And each one of these kind of valleys that are in here is a spectral line. So that shows that all of that incoming solar radiation has been absorbed. So now I hope nobody's head hurts. We're done with the science part. So what's it like to do what we do? So there's a look at life as an atmospheric scientist in the field. The first step is to outfit the team, and you can see there in the center, that's our crew from last year. These are all graduate students in the physics department at the University of Toronto. I've just issued them their gear. It costs approximately $2,000 per person to dress someone for the conditions that they'll be working in. And then a couple of days later, we flew off to Yellowknife. And on the lower left there, you can see us in our chartered aircraft getting ready to depart. So it's possible for me to stand in the middle of that aircraft, almost upright, and to just about touch the two sides of it if I put my arms out. It's a tight squeeze. I like to tell people that these things are loud enough that you listen with your thigh bones. And then you spend 6.5 to 7 hours in this aircraft and you arrive in Eureka. And this is the aircraft being marshaled into place. You can see that we got there and it was pretty much dark. On this occasion, it was after sunrise, but not very long after sunrise. So the days were quite short still. So there on the left is Eureka. That's it. That's all of it. The blue building is where we live and eat. That's the main complex. Directly behind that, or I should say, if you go off on the diagonal towards the bottom left corner, there's a garage, and then beyond that is the station fuel supply. So that has to contain enough fuel for the station to survive for 2 years in case the ship can't come in to resupply. Now, if you head right from there, you see Opal. That's one of our facilities. And to the far right side of the picture is the water lagoon. This is our fresh water supply. And you can see that we've actually cleared off part of it to skate on. And let me tell you that playing hockey at -40 is a little bit different. You find that the water vapor you release when you sweat freezes on the inside of your jacket. So you're warm enough, but you're just that close to being too cold. Power is provided by diesel, and the generating station is located just to the left of the water lagoon. So on the right side here is a closer look at the main complex, and also in the picture there is a very large iceberg. That iceberg is 6 or 7 kilometers away, and it was quite impressive. So then you, the next day, you hop in the Ford F-350 and you drive to the lab. Most people expect that we need some kind of special snow vehicle to do this. And in fact, when people first started working at this lab, they had one. But the truth of the matter is that we get little enough snow that the road to it is mostly clear, with the exception of a few epic snowdrifts from time to time, which are basically impossible to drive through. So there's the lab, the Ridge Lab as we call it, on the left. And on the in the center there and the right, we have some pictures of our crews at various times working on instruments. It is in these pictures typically somewhere below -30, sometimes as cold as -40. We're up on a ridge, and that has the nice effect of raising us above the coldest layer of the atmosphere, which makes it a lot easier to work outside. Along the way, you might see these guys. So this is the Eureka wolf pack. And the Eureka wolf pack is probably the best studied Arctic wolf pack in the world. A number of wolf scientists have been traveling there to study this pack for 40 years or so. And so they're more than a little bit famous. And we like to kid that they like to collect their appearance fees. Or you might see some of these guys. These are muskox, and they are built for winter. They, as you can see there on the left, they can get quite frosty, and it doesn't seem to bother them one bit. They tend to congregate in what are called family groups for the most part. So there'll be groups of, well, as perhaps as few as 3 or 4 and up to maybe 10 or 12. And then in the fall, the groups tend to congregate together into much larger groups. Or you can see these guys. That's an Arctic fox on the left there, Arctic hare, top right. And well, the Arctic fox eat the Arctic hare. And in fact, the guy on the left has just brought one down for his dinner. The fox on the right, he's looking up at me. I'm actually looking out my office window, and he has decided that that snowdrift just to the west of our building is the perfect place to have a nap in the sun. Now, if you were to step half a step beyond that, you would essentially fall off a cliff. Summer is quite a bit different. You have lots of flowers. You have an Arctic poppy there on the left, and purple saxifrage on the right. The hares are quite, that's when the breeding is finished, so they're growing by leaps and bounds, and you can actually see huge groups of hares, flocks. I'm not sure what exactly the word is to describe a group of hare. The wolves are quite fat and healthy, and the fox there is actually in the process of changing his coat from the dark color to the white color, and the muskox, he's just waiting for winter. You can see in the picture of the muskox just a little bit of what there is to eat in terms of vegetation, which is not much. Muskox and hare both must be incredibly efficient at extracting nutrition in order to survive in these conditions. Though not visible here, there are low bushes of willow, and they're not really much taller. They might make it up to maybe as high as 15 centimeters, but not often. The view is quite spectacular. Here we are looking from the station out to the south across Slidre Fjord, the fjord on which Eureka is located. The color, because of the angle of the light coming in from the sun, the colors can be quite dramatic, and the atmosphere is very clean. So the blues can be very blue, and the whites are very white. Looking westward now, along Slidre Fjord to Axel Heiberg Island. That is the maybe not so aptly named Cape Fair. Different iceberg in the picture there. And the blue that you see here is ice. So this is the ice that's been scoured clear of snow by the wind. And so you're seeing the blue color come through. Now we're looking from the roof of the lab out towards Cape Hare. Cape Hare is this big feature here in the background. And in the late summer and fall, there's a circulation pattern that starts up that always causes a stationary cloud to form. And it's got to be something that's fairly complex. Never quite figured out how the air is moving, but that cloud will form there and it will stay there. And you can watch that cloud not move while all the clouds above it are racing one way or the other. So this is looking from the lab towards Eureka. This would have been February 18th or so. And as I say, this is someone else's sunrise. So the sun's not rising where we are, but it's close. And that's why you can see all the oranges and yellows and pinks in the background there. It's a welcome sight to look down on, see that little bit of light and know it's there when, you know, there's nothing but the four walls and the 4 or 5 people around you in the dark. So that's what I have for you today. And I'd just like to express my thanks to eMERGE for the honors today. Thank you to my family, to Teresa, Alex, Andre, and Serena for all the support. Thank you to James Drummond and Kimberly Strong, the Kandak Pearl principal investigators. Thanks to all the Pearl operators over the years. I see that Paul Lowen, who was our first operator, has joined us tonight. And Paul has a milestone of his own recently. One of the pictures that he took while he and I were pursuing a Peary caribou has been made into a Canada Post stamp. So you can see that in the Arctic mammals that just been released. And thanks too to the Eureka Weather Station staff that have been a part of our journey for 16 years for all the camaraderie and help they've provided us. So back to you, Braden.
Thank you, Pierre, for the presentation and showing us a little bit of insight into your life. Also here, probably by voice or maybe by video as well, is Evan Ferrari from eMERGE. So at this point, we just kind of want to open up discussion. I'm sure there might still be some questions from people based on what we've just heard. And please don't be shy of the chat box. Just keep the questions coming as we're chatting, and Evan and I are going to work our best to kind of answer those questions and pull them out as they're coming along to hopefully get things addressed. But to start, I just kind of pulled some of the things when I asked, what's one thing that people want to learn about? There was a few answers, so I think maybe that's a good place to start as people kind of start thinking and dreaming up some more questions as we continue the discussion. So this one was just came and jumped out at me. You mentioned that it's on average very cold, like maybe -50 during the winter, but do you happen to know what the coldest temperature ever recorded at the Pearl Station was?
I don't. It would have been, I'm perhaps as cold as -54 or -55.
Oh my God.
I don't know if Paul, do you happen to know?
I don't. I think your guess is as good as mine there. I just want to say congratulations, Pierre. It's a well-deserved honor here.
Thanks very much.
I might not be able to stay much longer. I'm going to have to get the kids ready for bed, but
I can relate to that.
Yeah.
If we're talking about temperature, I've got the Environment Canada website up right now, and it's currently -31, but it feels like -44. But it's probably a dry -44, right? So it only feels like -41.
Well, yeah, that's kind of an interesting thing. So -44 means the wind is blowing. You know, when we're there, we like it to be -42 or colder, because when it's that cold, the wind stops blowing. So then we don't have to worry about the wind chill so much.
Wait a second. When it gets below -44, or sorry, I'm confused.
So when
the real temperature gets
below -42 or 40, somewhere around there, then the amount of air motion slows down dramatically, and so we tend to get very stable conditions, and then basically there's no wind.
Wow, that's remarkable. I've got a question for you, Pierre, and I know I've asked you some questions about this before, and I know that you were going to be looking at some of the numbers on it, but for the folks that are joining us tonight, Pierre, you brought up some solar panels from Canadian Solar here, and you put them around the Pearl station, and you're trying to evaluate the what you could get out of them. Have you seen anything from that study yet? I know that it was just sort of preliminary looking at the numbers at this point.
Yeah, so our solar panels, we installed 8 solar panels. 5 of them are still working. 2 of them are probably working, but their data collection computer threw a fit. And because we can't go there, we can't fix it. And 1 panel has stopped working, or at least we're not collecting any real data from it. It's been quite interesting to see what they've done. So 4 of the panels are oriented in the cardinal directions. So 1 to the south, 1 to the west, north, and east. And we can watch the sun move across them. And you know, one thing that I find quite interesting is that when the sun has moved past south, that we're actually getting a lot of light from all 4 panels in terms of the voltage that they're generating. And that was a surprise. I thought that, so this is when the sun is up all the time. I thought that it would be a lot more direction oriented, so that the south panel would be producing in, you know, the west or the east might a bit, but the north would be dark. But in fact, there's enough light in the ambient surrounding that even the north panel produces when the sun is to the south.
Wow.
So that is hopeful for us to be able to start producing power from solar panels, at least during that part of the year when the sun is up. Of course, that leaves us with 4 months of the year when the sun's not up. So we will not be able to go fossil free.
I'm noticing a question here from MP Lloyd Longfield. He says, to travel there, I hear you have a lot of approvals. What are the Government of Canada departments involved in Eureka? Or what's the approval process like getting into this research?
Okay. Hi, Lloyd. Good to see you. So we have to deal primarily with Environment and Climate Change Canada, and they have the responsibility for the weather station where we stay, and they also look after the runway. And in fact, they own the building that we use as well. So the first thing we have to do is have their approval to travel there, which would require a designation as essential personnel. We are in the process of discussing that with them. And as yet, well, that process is ongoing. After that, we have to also get approval from the government of Nunavut and make sure that we are satisfying their requirements. And, you know, of course, for our own benefit, we will be making sure that we do the 14-day quarantine before we get on a plane, because the last thing we want to do is send someone that's sick to Eureka, because it's a 12 to 18 hour trip turnaround for medical care should someone need to be medevaced out of there by aircraft. So we're being very cautious, very careful with this, and of course, so is Environment and Climate Change Canada. And you know, there's really no shortcut to doing any of this. So that's the situation we find ourselves in.
Pierre, I have another question about the data. So who uses the data that you're acquiring, and who uses it, and how do they use it?
Well, we are part of several networks of similar types of measurements in the infrared, with our LiDAR measurements, with our radar measurements. And so that data goes into the network archives, and from there it's used by many different groups around the world. Some of it for climate modeling, some of it for chemical transport modeling, So the measurements, one way or another, tend to find their ways into models, which are then used to evaluate aspects of the atmosphere you can't measure very easily, or the future state of the atmosphere, or what have you. They're also used directly to evaluate the current composition of the atmosphere. We have two with us today, Alexei Takamarov, who's one of our LiDAR scientists. And he operates an ozone differential absorption LiDAR, which measures the ozone profiles from something a few kilometers up to about 70 kilometers. And so that data is then used, among other things, to validate satellites. This time of year, we would normally be there in order to do what's called a ground truth for the atmospheric chemistry experiment. That's a Canadian satellite that's been in orbit for 16 or 17 years now. We like to joke that it's on its 17th of a 2-year mission. 17th year of a 2-year mission. So that's kind of a brief look at where the data goes and who uses it.
Pierre did mention earlier about what the process that you've got to go through to get to Eureka. Obviously, I'm assuming all of you realize that he is in Guelph tonight, that you couldn't get the appropriate approvals because of COVID this time around, and you're still waiting, I suspect, on that.
Yes. As I said, that we're in process.
Yeah. Gotcha. I've got a bit of a bizarre question for you. When you first got to Eureka, what surprised you?
So I first went in the fall of 1994. And the thing that surprised me was that even though those accommodations were not anything near what they are now, they were still much better than I expected. So it's actually quite comfortable to be in Eureka. And you spend, well, at that time it was about almost 3-hour flight up from Resolute on a Twin Otter, which is much slower than the aircraft we fly these days. And I mean, you see nothing. There's no indication that man has ever been there as you fly up on this aircraft. And then you bank and you come up the fjord and you pass over the weather station and there's a runway and you land. So to have seen nothing for 3 hours and then arrive there and find a hospitable situation was a very pleasant surprise.
So and I'm extrapolating here, but so are you suggesting that there isn't evidence of human habitation of the area historically?
Not once.
Obviously not now. Yeah.
Oh, historically, yeah. I mean, there are signs of the Thule, who are a migratory people that would hunt and fish in the area. And so we do find campsites and what have you of those folks. And there is one about 6 or 7 kilometers from the weather station. But beyond that, there isn't much to see. I mean, there are a few fuel caches here and there if you know where to look for them, but they're not at all obvious if you're not very close to them.
And by Thule, how long ago would that have been, that habitation, or that time that they were on the land in the area?
Oh, I couldn't even guess. It's been several hundred years, I would guess, but I don't know when.
You had mentioned that the accommodations had improved from 1994 to now, which is 16 years is my math. I'm a comedian, not a mathematician.
Stick to comedy, Braden.
But I'm curious what kind of things like what kind of accommodations improve, and what's the process for, you know, the team asking for the accommodations? Is it like something like, oh, we would really love, you know, a microwave, but is that more important than getting, you know, the newest scientific equipment up there? What is the process like of getting better and better accommodations, and how are those decisions made? And what's like the biggest accommodation change that's happened that you've noticed?
Well, that the big blue building that you saw there was built in between 2003 and 2005. And that essentially more or less requires, well, a memo to Treasury Board, nearly an act of Parliament. Is that a fair evaluation, Lloyd? He's nodding, so yeah. It requires a significant outlay on the part of the federal government. And so it's something that requires years and years of planning. I was shown plans for that building in 1994, and it was built, like I said, they started in 2003.
Oh my gosh.
So there's also military on the site, or just off the site. So, and then the universities that share the space. And I think people have brought up stuff, and I know the bar is stocked by different bottles from across Canada and around the world. And you're part of a network of research centers around the world as well.
Yes.
So I think you have visiting scientists as well, if I'm not mistaken.
Yes, we do. Yep. We have partners from the US, France, England. At the moment, I think that's in Japan.
Yep. And I was fortunate to visit the site and spend some time getting to know the people there, and students that are interning that are up there doing different work for PhDs or different programs that they're in. But it's just Pierre's maybe being a Canadian understating the importance of that site, and the level of scientists that are there are absolutely the world-class scientists that you'll find. Pierre being one of them.
Of course. I heard Lloyd bring up the idea that there's always, you know, well-stocked fridges of beer, and I just see another question coming in the chat of what's something or how do you spend your free time over there? Is there, I guess the first question is there a lot of free time with a lot of this research you're doing, and what sort of things do you do to pass that time?
Well, I mean, we do work pretty hard. We do tend to have long days, but you know, you can only do that for a certain length of time before you need to take some downtime. So, you know, we have the bar, as Lloyd mentioned, and we have a recreation room in the main building there with a pool table, ping pong, darts, shuffleboard, and then of course our board games and many movies. We can actually watch TV. It's no doubt the world's most northerly Bell subscription. And it works not too badly most of the time, although when the sun is in the wrong position, the signal gets overwhelmed by stray noise, essentially, from the sun. We have an amateur radio station. Because the location is so unique, we spend a lot of time outdoors hiking and that kind of thing. There's a gym that we can use to work out in. There's a couple of bicycles up there for riding around on. There's lots of wildlife to take pictures of. There's the occasional bear to scare us back indoors. Yeah, so I mean, we don't need to sit around twiddling our thumbs.
Right. Sounds like you were kind of prepped for this pandemic long in advance with a lot of practice up at this research station for sure.
There are some similarities, yeah.
Yeah.
But I didn't hear anything about a sauna, going into a sauna and then jumping into the Arctic Ocean in the wintertime. Is that on the agenda at all?
There is not a sauna. We would love it if there was, but there is not one.
I guess, yeah. We'll have to get those government approvals all set up.
Could you comment about the changing depth of the permafrost layer You had a scientist that was camping out on one of the fjords that came and visited us one night, and was researching that. And I know that you watched the depth of the sea, the ice thickness.
So the permafrost is highly variable. What we've seen is that what's usually called included ground ice is been melting. So this is quite surprising. What you end up seeing as it starts to melt is, you get water and then that washes away the top layer. And so you see that under, 20 or 30 centimeters of soil, there is this chunk of white ice. Once that's exposed, it starts to melt quite quickly. Around Eureka, where we've dug, it's permanently frozen below somewhere between 40 and 60 centimeters. And sometimes that's frozen soil and sometimes that's actual ice, depending on the local area. And it's been melting. We see the water seep up to the surface, and we see puddles where there's no flowing water, so that's clearly coming up out of the ground. It's certainly changing the landscape.
I just noticed another question in the chat, and I'm not sure how much you can speak to this, but Denise asks, can you compare what it's like to stay and work in the Arctic versus the Antarctic? Is there any notable differences in your mind?
Yeah, the scale of operation is completely different. The South Pole Station and McMurdo are several times larger than our effort at Eureka. It must be said, rather better supported funding-wise. Things that, and we do quite well in Eureka. It's just that, this is where we might see 30 people peak season in Eureka. McMurdo, which is at a similar southern latitude, would see 3,000 or 4,000. It's just a completely different scale of operation. And that means that the facilities are larger and in many respects better, simply because they've been around longer and have been developing for a longer period of time. It's easier to do things in Eureka because the South Pole and McMurdo, run by the National Science Foundation of the US, they're quite strict in how you do things. And so the approval process is significantly longer to get something into those places than it is to get them into Eureka. In terms of the being outside and getting the work done, South Pole is noticeably colder. Warm days there are in the minus 46 category, and that's a pretty cold day in Eureka. It can easily be minus 50, minus 60 Celsius at South Pole. McMurdo is warmer because it is both further north in that case and on the coast. So, at McMurdo in the summertime, it can be above zero, and it can be comfortable to walk around in a light jacket. But that'll never be the case, at least in current times at South Pole.
Thank you. I also just wanted to go back. I feel like in the subject of climate change and talking about things, Robert asked off the top of what you might think a good first step for climate change is, maybe for people in Guelph or for people around the world. What's a good first step that we can all think about when we're thinking about your research and what you've gleaned? What can we use to apply as a first step?
Well, use less. You know, so if any one of us makes a 10% change in our energy consumption habits, or our consumption habits in general, that doesn't, you know, look like a lot. But, you know, if 10,000 people in Guelph do that, then all of a sudden, you know, that's a noticeable impact. And then if all of Guelph does it, that's an even bigger impact. So, you know, we're in this kind of place where we need to do more with less, I suppose you could say. You know, we can't go backwards in time and not do the things that we're doing now. So we have to figure out ways to do them better and you know, and use less in doing that. So efficiency is, you know, a really powerful tool in all facets of life.
Good answer. Evan, I'm not sure if you have any more questions to ask or how the night's going to be continuing to roll along, but maybe we do one more question and then kind of wrap things up.
I just want to underscore what Pierre said. I mean, I don't think he could have been more profound. Very simple answer to a complex question is to use less. I mean, it's the basis of what we need to do right now. That's a great way of summarizing it, Pierre. I can't thank you enough for that.
Okay, well, I think on that note and that insight from Pierre, I think we're about to wrap up this event. So I do want to throw it over to Rasha for one last thank you, and then we'll close it all up. So hello, Rasha. Thank you.
Hi. Thank you all. What an amazing discussion. So with this, we reached to the end of our event. Thank you all for making it till the end. And great thank you to our 2021 climate change hero, Dr. Pierre Fogal, for his inspiration, and huge thanks to Braden and the Making Box team for hosting this event and for their support with the climate change hero since 2018. Over to you, Braden, for any thoughts. Thank you all and have a good night.
Yeah, I think you summed it up. Thank you so much. You can go to the eMERGE website for more information. I've been from the Making Box. If you want to learn more about adaptability or hosting events or anything like that, feel free to reach out to me. But that's it. Thank you all for coming and sharing and giving your time with us today. And thank you, Pierre, for all the insight that you've provided. That's it for now, I guess, unless Evan, you have anything else to say. Thank you so much. Feel free to go on with your night and let's all try to do that one thing. What can we, you know, do less of in our lives? So that's great. Thank you.
Have a good night.